It's raining in Africa. The Africans are delighted, and we also take the opportunity to deal with the technical issues of photography without missing too much out here. That is why this episode of Colourclass Namibia deals with the topic of colour spaces, camera settings, and above all, with the topic of monitor calibration targets. We have arrived at the last stop of our tour, the Waterberg Plateau Lodge. The 2 weeks went by in an instant, and we experienced, saw, and above all, photographed and filmed a lot. So let's take a look at the material we produced together. But we can't do without seeing any animals. During a break in the rain, we pay a visit to the white rhinos. The rare pachyderms were fed nearby during the ongoing drought, and therefore easy to find. Namibia is a country full of colours, and of course, we want to take pictures to take them home with us, process them, print them, or have nice photos. Now, let's take a look at 3 stages where you can influence colours. The first stage is the camera. You can set colour gamut in every camera. The second stage is the image editing software. Every image processing software works in colour spaces. And the third stage we want to look at are the calibration targets, meaning the colours that a monitor is set to. All 3 things have to be set correctly so that you can really use the full potential of your camera. You can set a color gamut in every camera. What most users do not know at all is that this color gamut, which is set here, always only applies to the saved JPEG. That means if you take pictures in RAW, nothing changes the RAW, because, as the name suggests, the RAW is a RAW file. This is the pure sensor data. They have not yet been interpreted, read out, or altered. Additionally, a small JPEG file is saved and, depending on what you have set, also a fully resolved JPEG. This JPEG has the color space set in the camera applied. What color space should I set in the camera? If you only shoot RAW, it doesn't really matter what you set in the camera, but if you photograph JPEG, you should set what your monitor can display in the camera. Now, the next question is, how do I set up my editing software? I'll show you an example in Adobe Lightroom and Photoshop. First of all, in Lightroom. This is a program that works non-destructively. Again, I only need to choose the final color space at the very end. It is very practical. Adobe Lightroom's editing module actually always works in Pro Photo RGB. This is the largest color space for photos, considerably larger than any monitor can display. This means that I have the most options here, and you also have a small advantage. For example, this CS2740 can display more colors in certain areas than the Adobe RGB color gamut allows. If I stay in Pro Photo as long as possible, I can also use these colors and make them visible. Therefore, it is very reasonable that Lightroom works in Pro Photo RGB. The color space is actually only assigned during the RAW conversion. Before, only metadata are saved, which are now used here and influence the display. But the actual conversion of the RAWs into the format I have defined only takes place during the export. Photoshop works a little differently. With Photoshop, I always have to define a working color gamut. In this case, I chose Pro Photo. However, the most common workflow uses Adobe RGB as the working color space. If an image is now opened that does not have this working color gamut, Adobe Photoshop asks me how to handle this image. One possibility is, of course, to convert the image, which has a different color space, into this Adobe RGB color space in this example. Another possibility is to leave the picture like it is. Here, it makes sense to choose your maximum usable color space. So, if you want to work as standardized as possible, then this is Adobe RGB. If you want to exploit the full potential of the monitor, which in some areas goes beyond Adobe RGB, then choose Pro Photo. Just like our camera, our brain also does an automatic white balance, and so that it does not cause me to perceive a neutral and correct image incorrectly, I have to calibrate the monitor. This is, as nice as it is, of course not a normal setting of a workplace, so it won't do you much good if I explain to you now how I would calibrate the monitor here for this environment. And that's why I'll show you the next step of calibration in a more realistic environment at a normal image editing station back in Germany. I think this is more like an average image editing station, and the rest of the episode we will only deal with calibration targets. Why do we need calibration targets at all? Well, we have to be able to perceive a perfectly neutral picture as neutral, and it can happen that our perception thwarts us. To prevent this from happening, the ambient lighting and the calibration target of the monitor must match. Let's take a closer look at how this works. A calibration target always consists of a relatively large amount of information. 4 of them are the most important. There is brightness and white point, gamma and color gamut. With 2 of them, we can make it relatively easy for us. We always set gamma to 2.2. Unless you would do something very special, but then you would know that. And I would always set the color gamut to the native monitor color gamut, because the native monitor color gamut is the maximum that the monitor can display. The color management I would actually do in the image editing programs. 2 variables remain: the brightness and the white point. Both the brightness and the white point of our perception are constantly adjusted. But if you're in a dark room and walk into a bright room, you can see in the bright room, maybe after a very short settling-in period, at least as well as in the dark room, and vice versa. It is the same with the white point. If you walk into a room where there are greenish neon lights, meaning old neon lights that look greenish, then you may stop briefly when you come in, but after a moment or 2, you won't notice it at all, and a white wall that looked green to you shortly before will appear white again. The brain makes permanent exposure corrections and corrections to the white balance. On the one hand, this is a great function, but if the white point and the brightness of the monitor do not match the ambient light, then it can happen that your brain interprets a neutral picture for you in terms of color, or too bright or too dark. And then we get problems in image editing. Now let's start with the brightness. The ideal is that the monitor is as bright as our ambient light. Then we're not blinded and the monitor image is not too dark either. We're not tempted to lighten a properly exposed image just so that we can see it better, but actually make the image too bright. Let's have a look at that now. I have now set the monitor to a very dark setting, which means that I will most likely edit the image too brightly. You just do it unintentionally, just to be able to see anything on the monitor properly. And then, of course, the picture is printed too brightly or will be produced too brightly by my service provider. Of course, this must be avoided. The opposite is true if the monitor is too bright. Then we're blinded and we tend to edit our image too dark, and our products also become too dark afterwards. Of course, we don't want that either. One question remains: what brightness should I now set? Well, the problem is, brightness is measured in candelas per square meter, or nits. And I don't think any of us have a really clear idea of how bright a nit or a candela per square meter is. So, just a piece of rough advice. If the room is relatively dark like this, you should get very good results with 80 to 90 candela. If the room is a little brighter, then go with 120 to 140 candela. I would not go over the 140 candela because, firstly, the monitor wears out faster, and secondly, the precision of the colors suffers a little. The last variable we have is the white point. For you to see a little more clearly on the monitor what I would like to point out, I have chosen not too colorful animals by nature and converted them into a black and white image. Let's take a look at how it should look. Now the monitor is perfectly calibrated. And this typical Lightroom grey and the elephants appear neutral to us. That's how it should be. Now we want to change the light. We are now simulating a situation in which there is incandescent light in our editing room. The light situation that you see here, namely that the monitor image is still displayed neutrally, is the situation in which we have no problem. I still see the neutral image as neutral, because my brain is doing the white balance on my central field of view. However, the bad situation is one where exactly the opposite happens. For you to see this, we are now switching the white balance of the cameras to incandescent light. What you see here now is the worst case. We are simulating a perception in which the brain has taken the peripheral visual field as a reference. Mind you, the lamps here in the background are still set the same. They still have incandescent color temperature. But now, our brain has said, this is neutral, and if we now look at the monitor image, then the totally neutral grayscale of this elephant image suddenly appears totally bluish. If we did not know that we are now subject to an optical illusion, we would simply edit this image far too yellow to remove this bluish cast. And that's exactly what shouldn't happen. So the question still remains, which white point do I set the monitor to now? Well, whether you adjust the ambient lighting to the white point of the monitor or the monitor to the ambient lighting is of course up to you. I personally would always go ahead and create the most neutral possible daylight situations, and also try to continue this with artificial light. That means that if I work in the evening, I would certainly not put any tungsten light bulbs in my lamps. The cheapest and simplest method would be if you get a so-called norm light fluorescent tube and socket to illuminate your workplace. You can just put them in the corner. This gives you a light that you know the exact white point of, and the next advantage is that it has a very high color rendering index. This means that these fluorescent tubes emit a very wide spectrum of light. It contains every color of white light. A print like this can only show all colors that are included when this specific light falls on the print. Basically, as a rule of thumb, start with 6000, 6500 Kelvin as the white point. Most people find this neutral under average environmental conditions. And now we have all the information we need to set a calibration target for these environmental conditions in the Color Navigator, the calibration software for the ColorEdge monitors. What remains now is to perform the calibration. All I have to do is to take the calibration sensor, which I put in the right place on the monitor. That's being shown exactly. I tilt the monitor back a little so that the sensor really sits securely on the monitor. And now I only have to start the calibration. What is happening here now is that the calibration software gives certain brightness and color values to the monitor. The sensor measures these color and brightness values. The software compares the target value with the actual value, and if there is a discrepancy, the software calibrates or corrects the monitor internally. The whole thing happens without loss and is therefore the preferred method of the calibration, namely a so-called hardware calibration. And the great thing is, with the Color Navigator and the EX4 calibration sensor on the CS2740, calibration takes just under 90 seconds.